Okay, so it's 1:45. I'm going to get started, mostly because there's no way for me to get through all these slides in the amount of time we have, no matter what. But we're going to try anyway. So my name's Chris Inacio. I'm at Carnegie Mellon University. Why don't you go ahead and do?
Sure. Rick Sauls, I'm a security architect at Akamai Technologies.
And so we're going to do a quick overview of some considerations for writing so the security consideration sections for RFCs. It's not going to be kind of 100% comprehensive. There's no way to do that in an hour. And just as a quick note, I'm not going to rehash what's in RFC 3552. There's still good advice in there, so go read that. But it is a little bit dated at this point. So
Sure. No, not.
yeah.
Next slide. So there is a 3552 BIS. Oh, sorry. So there is a 3552 BIS, and the author.
And it's probably going to be abandoned because in over a year we got 0 comments from anybody outside of me and my co-authors. So it's probably going to be abandoned soon.
So that's a horrible thing. So what you all should do after this tutorial is go back and read the update to 3552 and send it comments, because we should have a current security model and security considerations. Does everybody know what the security consideration section is?
How many are first-time attendees here at?
Oh.
All right, so let's cover that briefly.
Yeah, sure.
So every RFC more or less has to have a security consideration section, and that has to cover and we'll go over this at least somewhat, but it has to explain how you're protecting whatever protocol it is you're developing against the threats that you've outlined and what the measures are. Now, that could be a smaller enhancement to a larger protocol, in which case, you just really have to cover your pieces, but you have to understand what your threat model looks like and what it is you're doing to protect it. So we're going to go over some guidelines on how to approach writing that security consideration section. And how many people are old timers here? Yeah. And how many people are from the security directorate itself in the room who are here to heckle? Yeah, okay.
All right. Okay, so the basic document is still pretty good. It's very old. You can tell by the relatively low number. Updates that have happened since then is, I guess the biggest one is Snowden, and knowing that there are national scale actors scooping up all of the information on the internet so they can decrypt it later or analyze it later, or perhaps in the case of weak keys and things like that, do it in semi-real time. As Gil said, it's currently stalled. We really want to try to push this over the line. So hopefully you'll all go out and read it and give comments.
So I want to, if we look at the what's in 3552, we have an attack model that differentiates between kind of passive attackers, active attackers, and one of the things we want to explain to people is use an attack model, understand what the attack model is against your system, define what its boundaries are, and then describe how your protocol is protected against those things. So here's an attack model. There are others. You could use Stride. You could use a number of other ones. This is the cyber kill chain, and I'm going to talk about why this is kind of relevant to what we see as some set of current activity that's against attacks happening kind of now. And these are the phases that we view in this model that an attacker is going to go through, right? So they're going to do reconnaissance on your network. They're going to do development potentially. That's the SecureWorks modification. Weaponization of whatever they're going to inject into your system. Do delivery, which means that might be an email. That could be a physical type of attack of convincing somebody to put a USB key into a system that's inside your perimeter. Whatever it takes to do the delivery. At that point, we then start to do the exploitation. We install the next phase of it. We have command and control inside the system, and then we're going to do whatever our actual objective was. So this is an attack model, but it describes a bunch of different phases where if the goal is to block, step 8, then you have all those other phases at which you can defeat the attack. Go ahead. So that's a model that's really good against an attacker who really wants to establish persistence in your network, who's going to spend a long time observing your network, kind of really developing a customized exploit and do the kind of attack, but it might not be sufficient for all types of attacks. There's a much more simple case that's kind of prevalent. Go ahead. So here's some data from the Verizon Data Breach Report, and I'm going to step outside the video recording for a moment and kind of point at the slide. But so what we're kind of seeing here is this tells you this is seconds, minutes, hours, days, weeks, months for an intruder coming into your network. And what this says is that, and this is the time to start exfiltrating. And so what we see is in the previous model, what I just described as the kill chain model, we have an attacker who's going to spend a lot of time surveilling your network, building a customized implant, and exploiting your network. That's not necessarily always true. What we see now is a lot of smash and grab taking place as well. So attackers penetrate the network from the time that one of your users clicks on that mistaken attachment inside there. It's minutes before they're starting to exfil data out of your network. And they're doing it in brazen ways such that they don't really concerned if your defenses detect that they're exfilling that data. They're just hoping they can get enough out of your network fast enough that it doesn't make a difference. And
sure. So another kind of attack, again, which we've seen since the Snowden document dump, is pervasive and passive. They're just watching they for whatever the they is, and it could be your competition, it could be national scale, it could be government, it could be agents trying to disrupt government functions. But they're doing pervasive, watching everything within an area, a domain. It could be a particular BGP cluster, it could be the entire internet, depending on how much money they've got to throw at it. And it's collecting, if not just the content, or not the content, but the metadata. For example, my company we use Signal for intermessaging, right? And if they want to take out all of the Akamai people here, they don't care what the message is and what restaurant we're going to tonight at 7 o'clock for dinner, right? They'll just know that they can track all the communications and then figure out who all the people are and target them for either further surveillance or physical harm or whatever it is. So when people say it's just metadata, it's not. It reveals a surprising amount of information about the people being observed, and that's something we really have to consider when you're writing considerations. Not just the content of the messages, but the message headers, if you will.
And so this is somewhat covered in the current draft, but we really want to have change the conversation about what a passive attacker versus an active attacker is, right? So, under the generalized threat model here, right, passive attackers can see everything exchanged outside of your defined border. So I kind of want to reemphasize that it's really important when we do a security review to understand what the boundary is between what you consider inbounds and out of bounds. Now, the security directorate, when doing review, may disagree with your assessment of what your border is, because I know that I've complained about that. But at least then we can be talking about the same thing as to where the lines are, right? So if it's a pervasive, they can build a comprehensive behavioral model doing passive. And then also if you have a really good passive, then things like offline attacks. So how long does your crypto key last before you cycle it? For a passive attacker, you assume that they have infinite compute resources or some version of that offline, and they can do an offline attack, right? Active attackers can inject packets into the network. So that means that any packet you send between you and what other endpoint you're communicating with, they can inject another packet with that. They can edit the packet that you've sent. All of those kinds of attacks, right? So this differentiation doesn't necessarily quite cover things like denial of service, but it's important to understand what those two differences are.
So security considerations, the impacts. You want to make it clear as much as possible, what it is you are claiming to protect, or what it is you are worried about actually, and what it is you're not worried about. So say, for example, we are not worried about passive surveillance of every packet on the network. Well, that probably wouldn't fly anymore, but saying we're not worried about correlating messages from a cell phone to at home versus a cell phone at work, well, it's got the same caller number anyway, so that's probably okay. So you want to make sure that the security reviewer or reviewers, because there'll be at least two, they understand your document, what it is you're trying to draw as your security perimeter, what's inside that counts and is being protected, and then where this perimeter is going to sit. Right? If it's on the general internet, that's one thing. If it's only intended to run behind an enterprise or something else protected by carrier-grade NAT, that might be slightly different. Develop the attack scenario early on at the beginning. What are the things you're trying to prevent? What are the things you think attackers can do? I'll put a plug in for the certificate transparency, has a security architecture document that goes really into great detail describing all of the parties in the protocol and what happens if this one goes rogue or that one goes rogue and what the after effects are. Now that grew into a whole separate RFC, and I don't think most documents need that. But understanding who the parties are in the communications and what happens if somebody is corrupted, spied on, or otherwise led down the wrong path, I guess. Also it's good to know what doesn't apply. Okay, you can say, for example, oh, we are only using TLS 1.3 for message exchange, and then you don't have to worry about the whole crypto stuff, right? You just do it by indirection.
All right, so these are the set of things that we're actually going to cover as we kind of go through this update. So this may not hit some concern you have. If you want, you can come complain to me afterwards. You can blame all this part on me. But we're going to kind of go over communication security. So that's going to be some amount of passive but data collection. Soft middle networks. So kind of the design point of someone breaks into your perimeter device, and then once they're that far, it's kind of game on. DNS and its role in security overall. And then Internet of Things. And if we have time, I'll talk a little bit about phishing, only because it still works and it's fun to talk about. Okay, so communication security. So passive attacks collect huge amounts of information. I think everybody in the room should be pretty familiar with that. And some of the reasons why this is effective, right? Because humans are very much creatures of habit. I can bet the vast majority of you get into the office every day, pull up your computer, maybe you check your email first thing, maybe you check a couple of websites the first thing, but you probably check the same websites the first thing when you come in, and you probably do a fairly common order between going your email or your web. We don't need to know what the address, we don't need to know necessarily what the content of what you're going to look at is to know that you came into the office. We just need to know that you go look at these specific sites in order every morning to know that you're there. And that's the metadata problem. Because humans are creatures of habit, you leak that information just at the metadata level. Just by knowing IP addresses in succession, we can get that, right? So that's, the metadata level of what's leaking out of the network. That's going to tell us a lot of information. That's part of that metadata, right? So we can really enhance metadata analysis with just some really minimal packet inspection, potentially a little bit more active material. So I could do everything I described just a moment ago, just with IP addresses and port numbers. If I add a little bit of information to, say, look at what's inside the packets, I can get a lot more information then, right? Just banner grabbing of the protocols, I'll learn a whole lot more about you. So these are things from a passive collection and information leakage you really need to kind of go against, right? This is another case where understanding what that security boundary is and what set of information is inside the boundary and outside the boundary is really going to help understand what the defenses should be and what needs to be done to protect it, right? It gets even better from a passive observation point of view that if there are active middle boxes in there. So if you have an active middle box in the path and I can control some other point in the network, I can make sure that the active middle box, which may be doing behavioral changes to the communication, such as minimizing graphics and that kind of stuff by understanding what kind of operating system and host you have in your hand along the way. So if it knows that you have an Android device on a limited connection link, and the middle box is going to change what it asks for along the way, I can use that information from a passive point of view to understand what target operating system and screen size and all of that kind of stuff from your device along the way. So the middle boxes are going to potentially leak information about your connection as well.
Yeah, okay. I should also mention, right, so middle boxes are a source of friction.
Contention?
within the IETF, right? Obviously, they do things that many people find useful, and many people have bought and deployed many of them. They have also led to an ossification in many people's minds, and so we're looking at things like QUIC, this major new effort, which is, it would be designing a whole new transport, except that we have to tunnel it inside UDP, right? So it's like they used to say about the Spider-Man comic, right? Threat or menace, right? But people buy them for a reason, and you have to consider them as an actor in your communications. That's all. Sure. Oops. Just hit that page up. Yeah. I don't think there's anything here just to emphasize anything new from what we just said. The last two bullets, minimizing the clear information exchange. Obviously, some of that has to be in the clear for network routing. Chris mentioned, source destination IP and port, right? You need that 5-tuple, 4-tuple to get packets from here to there. But everything else, you should try to encrypt as much as possible. TLS-1.3 is looking at encrypting most of the initial exchanges. Not all of it, unfortunately. QUIC is looking at also encrypting it, and then there are people who come in from the hardware community who say, well, or the mobile operators who say, I need to see what some of this stuff is so that I can shape the traffic to minimize the resource consumption on my networks or on my devices, right? And so if you're going to disable that or prevent that, you need to have a good story and explain what the trade-offs are. If you can leak anything through the side channel, people will find it. And it'll show up in WikiLeaks. Sure. Soft middle networks. This is the Malamar of networks, right? It's got this hard, crispy shell on the outside, and inside it's just all soft and gooey and tasty. There was I forget who the art comic was, but he had there's a polar bear and he's reaching down inside an igloo and going, boy, once you get past the shell, these guys are delicious. And so that's a problem, right? People put a lot of strength or a lot of resources, and both financial and computing, on protecting the perimeter. And they don't worry as much about protecting the inside. What happens, typical examples on the financial community, the night cleaning staff comes in and plugs in a laptop, right? Or you look at what Mr. Robot or some of these other shows, right? You just plug in this USB stick on the net and, you're good to go because you've got nothing partitioned internally, right? You got a very hard outer shell and inside no protection at all.
Yeah, so just kind of keep going with that, right? I mean, the problem there is if you can get onto that outer perimeter, those outer perimeter defenses, you're good. Once you have that toehold in the network, you can move laterally through that network to get to almost any resource you want to, right? And that's really the big problem. And so if you have all of your authorization systems, all of those domains kind of tied together and easily accessible under that same kind of soft middle, then you're really going to lose. That's really the kind of the game over. They'll have complete access to everything, right? And that's understanding the trust relationships that you've built inside that network. And so, go ahead to the next slide. Yeah, so I'm going to keep going. So, right, so in your security consideration section, if you're making assumptions that that's not the case or what the case is, what the trust relationships necessary for your authorization model, your authentication model, state it, right? It makes it a lot easier to understand. It may not need to go into every draft, but make sure you understand what the attack model is and how you're authenticating and securing your model, right? If you're planning something that uses an enterprise security system, which is going to have, kind of a larger authentication system, or if this is designed for something for home where it's going to be a lot lighter, right? And to that extent, you want to employ least privilege into your design as much as possible. So if something doesn't have to have kind of the full privilege in various layers of your protocol or your stack, then they don't need to have kind of the full access.
Yeah, just one on the first bullet. So we often talk about how the IETF doesn't really do authentication and authorization, right? It just wants to get the bytes from here to there, along whatever path and as quickly as possible. But there are facilities, components, that do care and that do integrate, bring into the model third-party agents, such as, WebRTC has a rendezvous point, Tran, Turn, Stun, whatever they are. They all have the concept of an introducer. And so if you're doing something like that, certificate transparency has the logs and then the log monitors who, watch the watchers. So if you're building one of these kinds of protocols, keep in mind that there are multiple parties.
So we're going a lot faster than I anticipated. If you guys have questions, comments, or no rotten fruit, but anything else, feel free.
Can someone
you turn on the mic?
Turn on the mic? Oh, good. All right. Here we go.
Why do you call it the soft media network? And the second question, I want to make sure that the point that you want to centralize for this party is that the internal network between the parity is not we cannot trust it, right? Is this point?
Okay. So the first one is sort of easier. Don't leave because I want to have you restate your second question. But soft middle because you've got a very hard exterior and a perimeter to keep all the attackers outside. But if an attacker gets in, it's game over, right? And we've seen that with Office of Management and Budget. We saw that with RSA, where people, they got past some of the border guards and were able to just sit there for weeks or months collecting data and exfiltrating it. So it's just the idea that if you drew a series of concentric circles, and maybe you've got a core set of trusted machines in the enterprise that do your authentication and authorization, then you've got the workstations on everybody's desk, and then you've got the DMZ protecting everybody. That layer in the middle is the soft and crunchy. And then what was your second question? Can you repeat it?
I'm just curious, why do you call it the soft middle network?
Okay.
It's a very popular name industry, or just your name it because some background meaning.
I don't know how popular it is. We certainly talk about it when we go do kind of incident response a lot and say, this is getting a little off topic, but you really should be using more segmented design to segregate out different departments and that kind of stuff with authorization domains within an enterprise network. And instead, what we see very often at enterprises that have been infiltrated is they have a flat design on the inside, and everything's dependent on being able to protect that perimeter. We call that the soft middle.
Okay, thank you. I think I understand. Yeah, more clearly.
Ludwig Seitz, Swedish Institute of Computer Science. First, a quick remark. You just said IETF doesn't do authentication authorization. I think that people at ACE and OAuth would be very surprised to hear that. But,
Yes.
now to my real question. Could you skip back to the slide about active attacks? Was pretty much in the beginning. Sorry for jumping back. There's one point about active attacks I think might be good to highlight and to raise awareness about, and that is mix and match attacks and delay attacks and message reordering attacks. Because in IoT networks, this can be very, very disastrous when the attacker just switches to legitimate packets or delays the legitimate packets and sends it later and things like that. So if you would like a suggestion to add some text about those to raise awareness of these attacks, because they're pretty powerful and many protocols are not well prepared to deal with them.
Giovanni, SIDN. Just a small comment. When you're talking about before metadata, I think maybe one idea we could follow is to just simply follow Bush-Schneier terminology. Metadata is data. Simple. You get across nobody has any doubts anymore what you're talking about. So I think if you're more explicit about it, would make it easier for people to understand. So, metadata is data.
Okay.
That directly.
Yeah, maybe it's protocol data versus the application data. I think because most of the protocols we design are designed to carry data, and then the other bits that are in there are like to help the process happen. But I agree with you. Metadata is data at the naive level, the novice level.
And I think, Yavnir, I think a useful definition for the difference is that the data is the stuff that I really want to send, and the metadata is the stuff that I don't really want to send, but the network or the application needs to send just to get my data across. And so it's like the content of my email and then all that bunch of headers. I don't care about the bunch of headers, but email won't work without the bunch of headers. So the bunch of headers is metadata.
It's good put versus throughput.
Yeah. Okay, but that's not what I cannot put in my. Yeah, and that's obviously wrong.
Yeah.
So about the soft middle, I think the reason for that is there's usually a security team and a networking team, and the networking team wants to be free to do whatever they want, to deploy whatever way they want. They don't want the security team to tell them, no, you can't, you have to segment here, you have to put a firewall here. The security team can get all the perimeter. They can put as much firewalls and IDS and proxies and whatever they want on the perimeter, because that doesn't bother the networking people, but the networking people don't want them to interfere. And I don't have any idea how the IETF can have any influence on that political internal problem that lots of enterprises have.
Yeah, no, it's a really good point. Yes.
One more note on soft core of the network. with the move to microservices and sorry for the for the buzzword clouds, we will see more and more segmented perimeters. Like any enterprise network will be number of perimeters that is equal to number of services it provides, internal and external.
You're absolutely right, and you know, as we outsource more functions to cloud, it gets infinitely more complicated, and I happily included none of that in this.
Okay, so a couple words about DNS. It's a rendezvous protocol. I want to talk to www.ietf.org, and I have to translate that into an IP address, a set of numbers, 4 octets or 32 octets, right, depending. And it lets me then communicate. The name translation, it maps from mostly human readable names, right? I can still remember when the first URL appeared on a TV ad. I'm sure many here can. So we were all aware of these kinds of names, into network endpoints. It is a distributed database. Various people all around the world contribute their little part of the knowledge. And for the most part, it's the communication between the person asking, the client or their resolver, and the authoritative or the recursive guy at the end who's providing the answer. There's no real security. It just sort of works because people haven't messed with it too much. Not a great state to be in. There's a lot of work going on in the DNS community about this. It is like trying to turn an aircraft carrier, right? You got to proceed very slowly and watch out you don't hit any rocks. But because almost every machine that's on the internet, well, every machine that's on the internet is going to use it. And a large portion of the servers on there are participating. And it's plain text, both the protocol and the data that's in there. And that can be secured nowadays. But isn't widely so.
I just want to touch. Yeah, the battery's dead. I just want to touch a little bit more on some of these other records, right? So server records and you know how DNS plays into 509 certificates, right? So server records are great. You can look up what your LDAP controller or your AD is on your local network. So when you plug in your favorite computer to your enterprise network, it does that request. And then after it learns it, it memorizes that answer. And when you leave your enterprise network and go to your favorite hotel, it still asks for that answer. So wherever you work, when you walk into that hotel and connect to its public Wi-Fi network, your machine is asking for your AD name and not the public version, its actual AD name in your enterprise. So DNS really has a lot of information in there. And you're probably leaking information about how your enterprise is configured every time you leave the building. And the other part about that is 509 certificates are generally tied to DNS names. And so if you can take over DNS in any way, then all of your certificate chain signing and that chain can be compromised just by taking at DNS. Yeah, so I'll keep going. So DNS is a thing for me. Everybody should probably be familiar with the active attacks against DNS. I mean, cache poisoning always gets a lot of play whenever it happens. We know about the Kaminsky attack, which the linchpin of security to DNS request and response is the randomized request number. And if you can intercept that, you can give back any answer you want by injecting a packet with whatever response you want before the actual DNS server does, right? So that's pretty much a race condition. It's built into the protocol. That's how the protocol works. So that's one big problem with DNS. That said, we have some drafts. Well, they're not even drafts, right? We have some RFCs on doing DNS over TLS. We have DNSSEC, which signs the DNS responses, which means that you can check to see if the response is really the correct response. We need those to be more deployed than they are today. All right, so dropping below that set, we have passive observation, right? So as we just kind of mentioned, the vast majority of DNS really happens in the clear text. You know, just by observing something like someone going to read.amazon.com, you can tell that they're reading their Kindle books. So you know a little bit more about who the user is and some of the services they use. If you want to know what antivirus an enterprise is using, if you can see its DNS, just wait for the lookups that tell you what antivirus vendor it looks up on a semi-regular basis. And now you know what signature set to test your exploit against if we go the whole way back to the kill chain. So observing DNS really tells you a lot of information.
So as a result, when you're using DNS in your protocol, as most of them do, you have to understand, what how compact the sand is that you're building your foundation on, right? So security considerations, subject to all the weaknesses of DNS. Now, if you're using TLS and you've got a certificate that you can then match that name against what you thought the name was that you're connecting to, that will work. That's one way to tie it. If you've got arranged a priori to have pre-shared keys or passwords across, so if you're doing, a very simple password protocol, you don't want to send the password to the server because you have no way of identifying the server. You want the server to send you a challenge, and then you can do something with that, or keep it stored, in a hash. DNSSEC with a validating client. There are many true believers about DNSSEC. It's going to come deployed any day now. There is a DNS over TLS. There is also, folks are looking at how to get privacy for DNS. If I know the name, I know what you're doing in many cases. And in some cases, it may not matter. I think for most of the people who come to IETF meetings, their governments don't care too much. But there are governments where if you went to a particular website, you could be in trouble, right? If you went to, an AIDS research site in Kenya or something like that. And I don't mean any cultural biases. I'm just picking out places or homosexuality in Singapore, where we're going to meet next time. So there are places where just knowing what somebody is doing is risky to that person. And therefore, you want to make sure that you don't add to the risk of the end users. Okay, so understand the information leakage, understand the risks, and the trust relationship. Most people with a home network are captive to their ISP's DNS. For a long time, it used to be a fad that if you type the bogus address in the browser bar, you get an ad from your ISP, right? Or GoDaddy, this domain for sale. Because what they did is they said, oh, this name doesn't exist. I'll send you over to here to my captive ad server. Right? And so understanding who the parties are and who is controlled by whom, or whose worldview is controlled by whom, is another consideration to keep in mind.
Hi, just one comment on DNS, Giovanni, Sadian. Yeah, I'm just worried about as well DDoS attacks on the DNS because they make a perfect target. We have seen if you take down DNS providers like the classic Dyn attack, Twitter, Netflix all had problems too. So I know you guys didn't talk before about DDoS, but it's a problem. Like DNS is a perfect place for DDoS.
Yes.
So that's a pretty interesting one, and considering, I mean, most of the protections that can reasonably be taken, if you look at kind of Dyn, they were pretty well armored to an attack like that, yet it still succeeded, right? And DNS is it's the rendezvous protocol that ties these things together. And so we'll touch on that if I actually make it through the Internet of Things talk about, like, please stop putting bad endpoints on the net.
Yeah, sure, yeah, perfect.
As a side note, when you see layers where DDoS attacks could be targeted, it can be a bandwidth, it could be an application layer, right? But it also can be, of course, TCP/IP stack, endpoint TCP/IP stack, but last but not the least, the infrastructure. All this equipment that forwards and processes the packets. It can also be attacked. It is frequently attacked, If you run a network, it can bring your network down completely, like all of the routers, essentially. So even MPLS layer will fall apart. But as in all competitions of armor vs sabotage, it's always attackers go where it's softer. Right now, we're well fortified on application layer and bandwidth-wise, reasonably well. But I expect that attacks on infrastructure will rise in numbers in the next decade dramatically. So it's important to consider how you protect the infrastructure.
Okay, so yeah, no. So I'm going to caveat that neither one of us are, routing experts. So you can stump the chump at the mic right now. But so here's another piece of kind of routing, right? So the basic version, autonomous systems advertise their little slice of heaven to the world via BGP, right? And so it takes that prefix, it goes upstream. In the current version of the world, right, you may aggregate that, you may forward that along to another connection, etc., right? The real thing here is we have a bunch of reasonably good recommendations and best practices about how to deal with routing and routing filtering, and that isn't even getting into some of the other parts, but from a security research point of view, we would really appreciate if folks would actually start, executing some of that guidance a little bit more. Go to the next slide. Yeah, so just a handful of fun routing events that, kind of related to please do filtering and please pay attention. And, some of these are a little bit older than others, but still, Pakistan attempts to block YouTube, but advertises prefix globally, taking YouTube down across the net. If you're running BGP on your infrastructure and you're seeing an advertisement from someone that says I'm YouTube, maybe you should think twice about accepting that advertisement. China Telecom sends out 37,000 prefixes in 15 minutes, hijacking large parts of the internet through China. The spectacular point about that one is, in China Telecom's case, they actually have the bandwidth to absorb the onslaught that came from advertising all of those and routed it back out successfully. So China Telecom actually absorbed it, sent it back out. People did notice, but in that 15 minutes, China Telecom actually rerouted the internet through China and back out without losing data, more or less. And now for the parts of please filter your the advertisements because it's actually malicious. Is in February 2014, Canadian ISP was hacked and it was used to redirect traffic from ISPs selectively and generally in short segments, so like 30 seconds. It was used to do that to interrupt Bitcoin and Bitcoin mining. So there are real cases where you can use these kind of attacks to really great effect.
There was amazing case study by Dyn at the last NANOG, where they decomposed latest known BGP hijacking done by one American company to other American company. So I gladly forward you to the slides.
Yeah, so I mean, this stuff really does happen. There's some comprehensive databases out there. I don't really put it in here, but Route Views, which does some pretty comprehensive capturing of BGP. Unfortunately, that's going to be able to let you look back and see after the fact what happened. So we'll be able to understand the attacks and that kind of stuff. It does nothing about preventing them now, right? And so what can we do to prevent them now? We can do a lot better in filtering. BGP-SEC, it's a hard adoption problem. Its adoption, last I looked, is still around 6.5%.
You can also do monitor roads globally and find all the route leaks in close to real time. Colleagues from RIPE NCC do exactly that and do it well. We also do that and I believe this university research team at Isolaria at Italia also does very interesting research in terms of detection in next to real time.
Yeah, so I can comment. So one of the other events that I didn't put in here was a leak, I think, out of Brazil, and if I'm incorrectly implicating somebody, I apologize already, where RIPE detected it within a minute or two, and that wasn't an attack, that was a misconfiguration, and that was stopped after maybe 2 minutes of activity, where the RIPE monitoring really found it and and did that. All right, but so in general, there's a set of folks who are going to be working on a routing, and then there's a whole bunch of the rest of us who aren't working on routing, who might be working on something like authentication using OAuth or something. And you should understand that the path, you should make no dependencies in your protocol on the path a packet takes. You shouldn't assume that a path the packet takes is reproducible, right? Because any kind of BGP advertisement may potentially, perturb those routing paths such that they're not going to show up again likely in your lifetime. So anytime you think that you can trace route backwards and know how a packet got to you and you know where that attacker is, yeah, stop thinking that way. That's not the case. That doesn't even cover asymmetric routing, which is a lot more common than people want. So unless you're really kind of located router to router next to whatever enterprise you see that traffic on, stop doing that. The other part about this is, understanding that your network connectivity, even though a packet may go from the endpoint you have to the endpoint you want it to go to, it may be going through places you don't want it or don't think it's going through based on routing attacks. And you may not be able to see that in asymmetric cases. So these are all things you're going to have to get to the mic though. These are all things you're going to have to pay attention to, right? So understand what your trust anchors are and how you're authenticating.
There would be one beautiful illustration how things might get wrong with BGP. For example, certificate authorities for TLS. They exercise one particular method to authenticate you as a person or as a business, which can be exploited using BGP. So you can get yourself a perfectly valid CA certificate and use it to manage the middle. So exact case when people were relying on something they would think is fundamental, it's secure, but in fact it's not.
Yeah, that's amazingly bad practice to do, that version. You want this one?
No, you're on the roll.
Okay, so Internet of Things. So this is just my plea out there for anybody who's building a really small device and putting it on the internet to control whatever. Please take out all of the awfulness that is these little random things on there that create things like the Mirai botnet, right? Don't put a backdoor in there that can't be turned off. Get rid of the default passwords that are the same across all the devices. Please update your OS image on some kind of reasonably regular basis when you build your device. Please secure your software updates and make the device software updatable. Please actually use crypto. These are all things I'd really like to see in devices so that, we don't have, a million devices connected to the internet that are, able to take down Dyn, for example. Also, as I kind of go in this, there's not really, and none of these recommendations are specific to an internet, go ahead, specific to an Internet of Things device, right? They're the same as kind of any other endpoint on the internet. There's, really kind of two possible differentiators on Internet of Things devices, as far as I'm concerned from a security point of view, right? They may have a lot less computational power, and potentially they're cyber physical. So maybe this device that's on the internet actually can open a door or a window or turn a light on or off. Maybe it can unlock your house. That's another security issue in and of itself. But fundamentally, when I look at it, I want strong endpoint security in general.
Yeah, just before we get to this, the thing I find interesting about IoT is for any, as I've seen discussions about any particular crypto algorithm or a particular, certificate data format or whatever it is, somebody will come up with a use case and a part number where this piece is too small to do that. Right? Oh, all I can handle is, ROT 13, shift everything over halfway, right? And my part only costs 10 cents on a camera that I'm only selling for $19. So the economics really make themselves visible. The concern, or a concern, is those same design criteria are also being used in things like cars, right? We're starting to see cars get over-the-air software updates, or vehicle-to-vehicle communication is a working group here. Those things cost a lot more than $19 US dollars, right? Whatever. And have a lot more than a 10-cent part doing all of the crypto work in there. But they seem to come from the same mindset of people. And while a bad guy being able to flip my lights on and off is annoying, a bad guy being able to cause my car to accelerate is way more than annoying.
All right, so back to the kind of denial service, right? So if you put enough of those devices on the internet, I guess it would be maybe I have a sick sense of humor. It'd be interesting to see when the cars can do a denial of service attack against DNS.
Crash into the data center.
Driving down the highway. So one of the other things we really kind of see as and this is, I don't have a good answer for you, right? Which is kind of asymmetric protocols. They're spectacular for denial of service. If I can send a small request to a service and the response really outsizes that small request, and I can point that response at something else, then I've really amplified my ability to kind of do that, right? So, no? Oh no, he's telling me I can't do it.
That's asymmetric protocols without authentication.
Well, no, so that's actually what I'm.
Is present.
That's exactly where I'm going, right? Which is if you really have the need of building that kind of asymmetric protocol, really we want the authentication. We want the strength in there that makes it so that you can't send that response to a spoofed location, right? So don't create this kind of amplification ability for folks, right?
Sure. Beware zero round trip and TLS 1.3, because the TLS handshake is asymmetric, right? The client connects, the server has to do some work. And now you can do, in essence, UDP style attacks at the TCP level where you don't care if the server gets back to you, you just want to bring them down. And so that's an issue. Yeah, authentication helps, but sometimes the authentication protocol requires an asymmetric amount of work on both sides, on either side.
So you said about unit economics for IoT, right? And there's just no place for good engineering. But there is a good consideration in the case of when you compare it to the car. So I did really inexpensive car. And the unit economics aren't great, so I have no brakes, and I take it to the public roads. But pardon me, this is my unit economics. Should we allow these cars on public roads?
So we do see that happening right now with tractors in the Midwest of the U.S., right? Because they're downloading illegal firmware from the Ukraine because John Deere won't let them upgrade it. It's economics are starting to really make their presence known in designing security stuff. And that's either it's either really interesting or cool, or it's just another source of frustration.
How you will measure things like downtime of DAI when half of the East Coast was offline. Is it expensive? Is it more expensive or less expensive than building secure devices to begin with? Open question.
Yeah.
Yeah, and so just kind of a quick comment on some of the work that's already going on. There's probably other working groups who are tackling some part of this or have some interest in these topics, kind of related to Internet of Things. What does it mean to have kind of a safe home network, a safe small device? What's a low power? How do I do small object or small signing of data so that I can get it to a limited compute, limited device? So there's a bunch of work on there, and there's a lot of guidance. Go look at this draft, which I think is either expiring or expired, but it's got a ton of references of places to go get some more guidance on like a lot of these topics. I just want to add, I don't know if we're out of time. We have 5 more minutes, right? Okay. All right, what not to do, right? Don't invent a new security mechanism unless you really, really have to. And then please don't go invent a new security mechanism. I'm all for kind of the work on TLS and doing those updates, and we should leverage the places where we're building those kind of secure components and leverage those as much as possible. Inventing security mechanisms everywhere is a real problem, right? And don't redefine security terms for something else in your draft. It drives at least this person who's reviewed documents absolutely crazy when you've decided that you're going to have a nonce and it's not a nonce. Things like that, yeah, don't do that. No. If you want to do it?
Sure. So I'll be the optimist. So what to do? The Crypto Forum is a working group within the IRTF, CFRG at IETF.org, for example, led by Alexei Meldikov and Kenny Patterson. Kenny got famous for breaking TLS over and over and over and over again. They will help. And the first thing if you do is you come and say, look, I got this great new crypto algorithm. They'll tell you to go away, right? Reasonably so. The second bullet is actually one of the most useful ones. Make the crypto upgradable, right? Don't bake in a crypto, everything is done like DNSSEC does this, right? They picked one algorithm and one key size. And so it was a lot of work to change the keys. Use identifiers. There are various registries in the TLS work, in the elliptic curve group that Daniel and I co-chair, that have OIDs for things. So just make it easy to roll stuff out, because if you're successful, your protocol will exist for a decade, and 3 years into it, somebody will find a way to crack the crypto that you're using. Okay. Think about security early. Bake it into the design. Think about who the parties are that are communicating, what kind of protections you want to have or you would like to have but can't see a way to solve right now. Even just putting down the unanswered questions early on in the draft will help, and people will volunteer to help you figure that stuff out. Understand what the boundary is. Are you working on somebody's laptop? Are you working on somebody's stateless Chromebook where everything is off in the cloud? Are you working in an enterprise behind or a home network behind a NAT, and so on? And leverage the existing standard security track mechanisms. I don't know what the question is, but the answer is almost always going to be TLS, right? And ask for help, either in the group you're in, or speak to the security area directors, or send a note to SAG, S-A-A-G, which will catch sort of the overall security area group in the ITF. And people have come up to that and presented ideas that have, people have adopted. There's a meeting on rekeying, which was just brought up recently. Yeah, ask for help. Don't go off and try to invent something.
1 minute. 1 minute. So phishing, yeah, not really a security consideration thing, but because it still works, I think if you pay any attention to the news, especially in the US, where we've managed to phish the election, yeah, clearly phishing still works. Please don't click on the link in your email. Please do not open the random attachment. I've really, random search on the internet for, there's some sites that have phishes in general. I love this one. So this is a phish for American Express. And in the bottom, the part that's circled in red, it includes an email address for phishing emails. I love that. So you're getting phished with a phish complaint link in it. But yeah, if we look at initial vectors into infections, email is still really high up on the list, and email is still really high up on the list because email still works. If you have a large organization and you have 1,000 people, you only need that one person who's willing to click on the link. So, that cute cat and the little cuddly bear and the puppy, they're awesome. I mean, they get you in pretty much every time. All right, thanks for coming, everybody. If you have any more questions, we'll be around for at least a few minutes. Rich is probably trying to figure out if he can get into his room yet. That's surprising, but thanks.
Well, specifically because I'm working on a project called Signing HTTP Messages, and we have a security consideration section that is not in the spec. So we split the spec into two. It has a very short spec and a huge security consideration side. Do you usually want to see both of those things just together at the same time, or do you want to see them separate?
That's a hard question.
I thought it was going to be a mundane.
No, so anybody chime in? I actually, for the case you just described, I would be fine with it being separate. What I personally find irritating is the one that is a little add-on protocol to some other protocol which says, go check the security consideration